Hi, I'm Ms. Vung. Let's have a look at multi-stage experiments. What are multi-stage experiments? Well, if we had 3 cards, what is the probability of picking a queen? Or what is the probability of picking a queen twice? So we pick a queen and then we do it again. That is called a multi-stage experiment. So in multi-stage experiments, we can solve them by using a tree diagram or a table. So let's have a look at an example. So imagine you have 3 cards, a jack, queen and a king. We will choose one, then put it back, and then we will then choose another. What combinations could we get? So in the first pick, so when we first pick the card, we could get a jack or a queen or a king. Now if we took a jack, and we put it back, what can we get in the second card? We could get a jack or a queen or a king again. If we picked a queen in the first turn, what could we get in the second card? Jack, queen or queen. And you can see that for the king will be the same. So when you set out the tree, make sure that the first pick or the first stage is here, and then the second stage is here. Then we can list the outcomes. So we can obtain a jack-jack or a jack-queen, jack-king, queen-jack, etc. And we can see that there are 9 outcomes. How do we figure out how many outcomes? Well, there's 3, and for each of these 3, there's another 3. So 3 times 3 is 9. So to figure out the number of outcomes, it's handy to multiply each of these stages together to get the total number of outcomes. Example 1. What is the probability we choose at least one jack? So we look at the outcomes. So at least one jack means, well, all of these 3 outcomes at the top because we have one jack there. And just one outcome here for this jack and one outcome here for this jack. Or in other words, 5 out of 9. So the probability is 5 out of 9. What is the probability we choose the same card twice? So we can obtain jack-jack or queen-queen or king-king. So there are 3 out of the 9. So a third. We can also use an array or a two-way table to describe it instead of a tree diagram. So for the first card, this time we're going to put it to the left, and the second card to the right. And we can write down the outcomes: jack-jack, jack-queen, jack-king. So we read from left to right. Try not to mix them up, otherwise it becomes very confusing, because there'll be questions such as, what are the probability of picking a jack first? And you need to see the order. So the probability of each of those can be calculated by multiplying each single probability across. So the probability of jack is a third times probability of jack a third, which gives us a 9. So what is the probability we choose at least one jack? So we look at the table and we look for at least one jack. So that's jack-jack, and that's jack-queen, that's jack-king, and then there's queen-jack and king-jack. So let me try and show you by pointing over it. Okay, so at least one jack will be, see jack, so these 3, and then these extra 2, so 5 out of 9. So it's a little bit different to the tree diagram, but it gives us the same answer. What is the probability of rolling 2 dice that add to a sum of 5? In this case, it's handy to do a two-way table because we can quickly see what the sum of 5 is. So we can circle the sum of 5 here. These add up to 5, so there's 4 out of 36. Or in other words, simplifies to become 1 out of 9. Example 4. When tossing a coin 3 times, what is the probability of obtaining 3 T's or 3 tails? Well, would you do a tree diagram or the table? In this case, because we're tossing it 3 times, so 3 stages, we're going to use a tree diagram. So here's the first toss, the second toss, and the third toss. And the outcomes are H, 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 T, etc., etc. So you read from left to right. So now we have 2 times 2 times 2 is 8 outcomes. So let's answer the question. What is the probability of obtaining 3 teas? So that one there out of 8. And you can always check if you've done your tree diagram probabilities correct, because if that's 1 over 8, that's 1 over 8, 1 over 8, 1 over 8, and you add them all up, it should always add to 1. Oops. So probability of 3 tails is 1 over 8. When tossing a coin 3 times, what is the probability of exactly 2 tails? So here we have tail, 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 head, tail, 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 head. So exactly 2 tails is 3 out of the 8. What about at least 2 tails? Well, at least 2 tails means 2 tails and the 3 tails. So we can see that there's 4 out of 8, and we have to simplify. It is 1 over 2. What about at least 1 tail? So everything here has at least 1 tail except for the 3 heads. So at least 1 tails means the 7 out of 8. But you can also work it out as the probability of you can also work out the probability of at least 1 tail by doing 1 minus not getting a tail, because that would also give us 7 over 8. So recap, at least 1 tails means these 7 over here, so 7 out of 8. But you can also do 1 minus the one we don't want, which is that 1/8. 1 minus 1/8 is also 7 over 8. Example 8. Ella has a choice of 2 entrees, which are soup or salad, 3 mains, which is fish, chicken or steak, and 3 dessert, which is ice cream, lemon tart or tiramisu. Draw a tree diagram to show all her possible dinner combinations. So our first stage is entree, then our second stage is our main. So the entree is soup and salad, then our main. So if she has soup, she can have fish, chicken or steak. If she has salad, same 3 options. And then for each of these, she can also have 3 desserts. So we can see that now the number of outcomes is 2 times 3 times 3, which is 2 times 3 times 3 is 9 times 2 is 18. So there's 18 outcomes. So soup, fish, ice cream, or soup, fish, lemon tart, etc. We can also write the probabilities on these. This time it's a half and a half. For fish is and chicken and steak, there's 3, so this will be a third and this will be a third. And to work out the probability, we would go soup and fish and ice cream. Remember the word and in probability means times, so it'll be a half times a third times a third. But let's not do that, let's do the next bit first. What is the probability she chooses soup, fish and lemon tart? Soup, fish and lemon tart. That's 1 out of the 18. And we're going to do it in 2 different ways to check our answers. So probability of soup, that's a half. And fish, and means times. Fish is a third. And the probability of lemon tart is, well, there's 1 lemon tart out of 3 desserts, so also a third. And when you multiply through, you will surely get 1 over 18, which you can see that soup, fish and soup, fish and lemon tart is 1 out of the 18 choices. What about she chooses fish? Well, if she wants to have fish, that means these 3 options up here or these 3 options down here. So that's 6 out of 18, or in other words, a third. But we can also work it out by saying that she wants anything, which is probability of 1. When you want anything, that means 100% probability, times fish, which is a third, times anything. So she wants any entree, fish, and any dessert. So we do 1 times a third times dessert, which is 1. So you get a third. So it's the same as counting the outcomes over the total, 6 over 18, which is a third. What is the chances or probability she chooses salad and chicken? So salad and chicken. So salad and chicken. So probability of salad is a half, chicken is a third, and any dessert. So a half times a third times anything is always 1. So a half times a third is a 6 times 1 is also a 6. So salad times chicken times anything, 1. So 1 over 6. And let's double check. Salad and chicken is these 3 options. 3 out of 18 is 1 over 6. So we're correct. What is the probability she doesn't choose lemon tart? You can do this in many ways. For example, no lemon tarts means the probability, so it means 1 minus choosing lemon tart. So 1 minus, well, the probability of choosing lemon tart is 1 out of 3. So it will be 2/3. Or we can count the outcomes. The ones with lemon tarts are no lemon tarts are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 outcomes without lemon tart out of 18, which is also 2/3. Or you can do what entree do you want? Any, so that's 1, times what main do you want? Any, which is 1, times what dessert do you want? Tiramisu or ice cream, which is 2/3. So 1 times 2/3, also 2/3. So you can see probability can be solved in many ways. What is the probability she chooses soup, fish, and lemon tart? But this time, Ella has a choice to omit the entree or the dessert. So she can skip the entree. So one of the options will be none for entree. And then for the none option, she can still have fish, chicken, or steak. And then for the dessert, she can also have a none option. So I'm not going to fill in the none option for the entree, but you can imagine we have to draw 3 more mains for the entree and then a lot more dessert. So we are going to get more, a much bigger tree diagram. So instead this time, let's work it out by working out what soup is, what fish is, and what lemon tart is. So the probability of getting soup is now not 1 out of 2, but 1 out of 3 because she could choose none as an option. Then fish is still 1 out of 3, and the lemon tart is now 1 out of 4 because she could choose none as an option. So now the probability of choosing soup, fish, and lemon tart, given that she can skip the entree or dessert, is now 1 over 36. What is the probability that she can choose all 3 courses? And remember, she can skip entree or dessert. So to have all 3 courses, so to have soup or salad is 2/3. To have the main is 1 or 3 out of 3. And to have dessert is 3 out of 4. So when we simplify that, cross the 3's out, and then we get 1 over 2. So she chooses to omit the entree and or dessert. Sorry about the typo. What is the probability she chooses only 2 courses? So let's translate that. What does 2 courses mean? It means that she can have the entree and the main, or she has the main and the dessert. So or means plus in probability, and means times. So with entree and main, it means she can have the soup or salad, so 2 out of her 3 choices, and main, so times 1 because she can choose 3 out of 3 choices for main. So when you see anything in your head, you write 1. If you can have anything, that means 100%, so 1. And then can she choose dessert if she's having main, entree, and main for this section? No desserts. So what's the probability of no desserts? That's 1 out of the 4. And again, we said or means plus. So here we have entree, 2/3, so soup or salad, times anything for the main, 1, times a quarter for the dessert. Or, so we're going to put plus there. We can have no entree. So because we're having main and dessert, so no entree is 1 out of the 3. Then main means anything, so 1. And then dessert, we have 3 out of the 4. So entree and main and no dessert. No entree, main and dessert. So we simplify that. We have, instead of crossing the 2 and 4, where we usually simplify fractions, because we know we're going to add the fractions, a good tip is to keep the denominator the same. So 2 out of the 12 plus 3 out of the 12, which is 5 over 12. And lastly, if she can choose to omit the entree and dessert, what is the probability she only choose the main course? So no entree, main, yes, no dessert. So no entree means 1 out of the 3, and main, and anything means times 1, and no dessert, so times 3, sorry, and no dessert, so times 1 out of the 4. So we have 1 over 12. So recap that. So only main course means the no dessert, so which is 1 over 3, and so times main, 3 out of 3, or 1, and so times no dessert, which is 1 out of 4. So to recap from today, we should remember whenever we say anything means times 1, and whenever we say the probability of not that, we do 1 minus the probability of that. Thanks for watching. I'll see you next time. Bye.